Now, in the previous lectures, we have covered till step 1.5. In this lecture, we will be covering basic hashing. Once I cover this, we will be covering everything related to basics that we require in order to start with DS Algo. So without waiting, let's get started with the hashing lecture. So we're solving a lot of interview problems, isn't it? But whenever you go for interviews, the first round will always be coding round. So in order to clear that coding round, you have to actually give a lot of similar coding rounds in your preparation. So one such coding round is Code Rush X by Newton School. This is India's biggest competitive programming contest that is happening in the year. Why do I say that? Because it has prizes worth 10 lakh rupees. So what you need to do is, there's a link in the description. Go to that and you can click on register. The moment you click on register, you will get a form. You can sign up with Google or you can fill up your details. And the contest is on 28th of January. Now, just need to register. Post that, you will be participating. There will be 8 questions that you have to solve in 3 hours. After that, there will be a thorough plagiarism check and the results will be announced. The first prize is 1 lakh rupees. The second is 50,000 and so on. And there are a lot of prizes for other people as well. Till the top 100, you can get a lot of goodies. And going forward, you will also be getting a lot of gift vouchers. So the prizes are worth 10 lakh rupees. So what I will recommend you is the link in the description. Make sure you go and register and participate in such contests because this will help you in your preparation journey. So without waiting, let's get back to the video. Now, when I talk about hashing, it is one of the most important topics in DS Algo. If you do not understand hashing, you will not be able to solve a lot of problems in data structures and algorithms. So please do not miss this lecture because I'm going to teach you hashing and I'll be using pseudocode. So language will not matter. Everything that I'll be teaching will be in terms of pseudocode because for loops are similar in C++, similar in Java and Python. So once you understand the pseudocode, once you understand the concept, you can actually code it in any of the languages that you are following this particular course in. So in order to understand hashing, let's take an initial problem. Imagine you're given this particular array and now suddenly I come up and say, hey, can you tell me how many times does 1 appear in the array? And you can say that, hey, 1 appears twice in the array, right? Because 1 is appearing once here and 1 is appearing once here. So 1 appears twice in the array. And again come up and say, hey, can you please tell me how many times does 3 appear in the array? Now you'll be saying 3 appears once. Now imagine I again come up and say, hey, can you tell me how many times 4 appears in the array? You'll be saying it doesn't appear in the array. Now imagine I again come up and say, hey, can you tell me how many times does 2 appear in the array? You'll be like 2 appears twice. Imagine I again come up and say, hey, how many times does 10 appear in the array? You'll be like, hey, listen, 10 doesn't appear in the array. So 10 is appearing 0 times. So given an array and you're asked a lot of times, very, very important points, very, very important point. You're asked a lot of times. First, you might be asked for any given number, then any other number, then again the same number. You could be asked for any given number of times for any number, and they might ask you how many times it appears, and you have to tell me. Now, what is the first approach that comes to your mind when you think about it? Because you know for loops, right? The first approach that comes up is, hey, if someone says the number is 1, the first approach that comes up to my mind is, I will iterate through the entire array. What I'll do is I'll take this 1 and I'll compare it with the first guy, 1, and I say yes. And I'll take a counter variable, which is 0. I'll say this is equal to this. So I update it to 1. Next, I'll go to 2 and I'll say, is this equal to 1? I'll say no. Next, I'll go to 1 and I'll say, this is equal to this. So the counter, which was 1 previously, will be updated to 2. Next, I'll go to this and I'll say, is this equal to this? No. Next, I'll go to this and I'll say, is this equal to this? And no. So the counter stays at 2. So if I have to write the brute force method in order to find how many times it appears, can I say it will be a function which takes a number. I'm writing a plain pseudocode. It will be a function which takes a number and probably an integer function because it has to return how many times it appears. And you can be like for loop int I, or rather you also need the array in the function. So go ahead and take the array as well. Int function and probably array. Again, I'm writing the pseudocode, guys. I'm just writing the pseudocode. Please focus on the logic. So can I say, probably I'll take a counter equal to 0 and I'll say for I will loop from 0 and I'll loop till the last of the array. You already know this. How do you loop in the array, right? And you will say, hey, if array of I is equal to number, can I say counter equal to counter plus 1, and I can end this for loop, and I'll say return counter, and this will be my code. Can I say this? Yes, I can say this. Why does this work? Because it's very simple. If you're given a number 1, that number 1 is given over here and the array is given over here, and you iterate through the entire array. What is 0th index? This is this. What is after this first index? This is this. And what are you doing? You're saying array of 0 equal to 1. Then you are increasing the counter. So eventually you will iterate through the entire array and the counter value will be updated at the end of the for loop. Once it is updated, you return the counter, correct? So in order to find how many times 1 appears in the array, what you can say is, hey, function, take 1 and take this particular array and tell me how many times it appears, and it will return you 2. In order to find out how many times 3 appears, you'll say, hey, function, take 3 and take this particular array and say how many times does 3 appear, and it does a linear iteration. It goes to every element and checks if it is equal, and it counts it, and at the end of the day it returns the count. Simple. So if I have to ask you, what is the time complexity? Can I say I'm running a loop for bgo of n times, and there are certain number of operations that we are doing, but we do not calculate that in time complexity. So can I say I'm running the loop for n times, thereby the time that I'm taking in order to compute how many times a number appears is bgo of n. So for this, I will take bgo of n. For this, I will take another bgo of n. For this, I'll take another bgo of n. For this, I'll take another bgo of n. For this, I'll take another bgo of n. So can I say for 5 times, if I have to do 5 times, like these are 5 numbers. For 5 numbers, if I have to find how many times each of these numbers appear, can I say the time complexity is 5 into bgo of n? I can say. And imagine if I give you a lot of such numbers, like a lot of such numbers. If I give you a lot of such numbers, and imagine there are q numbers. I give you q numbers, and for every for every number, you have to tell me how many times it appears. Can I say the time complexity will be q into n? Can I say the time complexity will be q into n? Because for every time you are taking a for loop and computing it, so thereby the time complexity will be q because there are q numbers, and for every time you are computing n, so the time complexity boils down to q into n. And this is something which might not be good. If imagine q is very large, just imagine I'm giving you q to be 10 to the power 5. I'm giving you 10 to the power 5 numbers. And imagine I give you an array size. I give you a huge array of 10 to the power 5 size. Then what will happen? Then it will be bgo of 10 to the power 5, because 10 to the power 5 numbers will be there. And the array size is 10 to the power 5 because it's a huge array. So the number of operations will be 10 to the power 10. And the number of operations is 10 to the power 10. How many time, how much time will it take? If you remember, I told you 10 to the power 8 roughly takes around 1 second. Most of the problems you'll find on DS algo will be taking 1 second or 2 seconds. So if I'm taking 10 to the power 10 operations, how much time will it take? It will take 10 to the power 10 seconds will take approximately 100 seconds. How do I get that? Very simple. If 10 to the power 8 takes 1 second, then one operation will take 1 second by 10 to the power 8. Then 10 to the power 10 operation will take 1 by 10 to the power 8 into 10 to the power 10, which is nothing but 10 to the power square, which is nothing but 100 seconds. So 10 to the power 10 will take 100 seconds, which is a lot of time. You cannot wait for 1.5 minutes for a program to execute. This is where something like hashing comes in. It's a technique which will help you to do it in a much faster way. So if I have to define hashing in extremely naive terms, what is it? It is something like pre-storing and fetching. This is what hashing is. Pre-store something and fetch when required. Let's understand this in depth. Now this is an array. Okay. Now imagine the problem statement states the array will at max have numbers till 12 or 15. Let's say 12. At max, it will have 12. What does it mean? Over here, you're saying 1, 2, 1, 3. So at max over here, it is 3. But imagine a problem statement where I state, I'll give you an array and the array at max will have 12. Over here, it is having 3 at max, but the array can have at max of 12. So what hashing says is, okay, I know I can have numbers from 0, 1, 2, 3 till 12. So what I will do is, I will create another array. Okay. Remember this. I'll create another array and I'll call this as hash array. And in this hash array, what I'll do is I'll say 0, 1, 2. So what I'll do is I'll create an array of size 13. And I know the indexing starts from 0 and the indexing will go on till 12. And I'll assign everything as 0 initially. And this is something which I'll call as hash array. This is something which I'll call as hash array, or you can call it as a frequency array as well. Now, what I will do is I will do some pre-calculation. Remember this. I will do some pre-calculation. Now, what is this pre-calculation? It's very simple. I go to the first number, which is 1, and I say, okay, you are 1. So I will go to the first index and I'll say, hey, can you just remember that I have 1, 1? So he will say, okay, I'll remember you have 1, 1. Next, I'll go to this 2. So it will come to this 2 and say, hey, can you remember I have 1, 2? He'll say, okay. Next, I'll go to this 1 and it will say, go to 1 and say that he has 1 more 1. So he goes to 1 and says, you have 1 more 1. So he says, okay, I know I have 2 1s. He'll go to 3 and say, can you go and remember you have 1, 3? He will do that. He goes to 2 again. He says, go and remember you have 1, 2. So 2 increases to 2. So apparently, the moment you have traversed for all the elements in the array, the hash array, if you properly observe, in one index, because 1 is the number representation, in 1 it states, I'm appearing twice. In 2 it states, I'm appearing twice. In 3 it states, I'm appearing once. And all the others are marked as 0 because they do not appear. So now, this is the pre-store that you have done. This is the pre-store. This is the pre-fetching that you have done. Now, what will happen? Now, you come over here and you say, hey, listen, how many times 1 appears? Now, you do not loop and find out how many times 1 appears. What you say is, hey, how many times 1 appear? I have done a pre-fetching. I'll go to 1 and I'll say, it appears twice. I get twice. For this 1, I go and say how many times it appears. And I'll get this value at hash of 1. Instead of iterating in the entire array, I say hash of 1 and it tells me 2. For this 3, I'll say hash of 3 and it will give me 1. For this 4, I'll say hash of 4 and it will tell me 0. For this 2, I'll do hash of 2, it will give me 2. For this 10, I'll do hash of 10, it will give me 0. For this 12, I'll do hash of 12, it will give me 0. So can I say I just did a single pre-computation and that apparently solved all of my queries in one go? So if I have to code this up, can I say I'll first be given the size of the array. Imagine this is 5 size array and 1, 3, 2, 1 and 3. So given this array, then probably I'll give you the number of numbers for whom I require, how many times they appear. I tell you I need for 5 numbers. And the number is first I'll say how many times 1 appears. Next I'll say how many times, let's say 4 appears. Next time how many times 2 appears. Next time how many times 3 appears. Next how many times 12 appears. So 5 numbers for which I have to find how many times they appear. So this is the size of the array. This is the array. How many numbers, like how many queries are you giving? And these are the queries. 1, 4, 2, 3, 12. Tell me how many times 1 appears. Tell me how many times 4 appears. Tell me how many times 2 appears. Tell me how many times 3 appears. Tell me how many times 12 appears. So I need to take all of these input. So it's a very simple way. First n and then scene of n. Then you declare the array of size n. And then you say for I equal to 0, I lesser than n, I plus plus. Then you go across and say scene of array of I. Perfect. We've done this. What's the next step? You have to take the query. Let's first I'm taking up all the inputs. Okay. Scene of Q. So you can run a while loop like Q minus minus. And then you can say, take me the number and scene of number. So this is what is the input. First the array, then the queries, and for every query, the number. Now you need to tell me how many times the number appears. So this is where you do some pre-compute, and this is the fetch method. This is where you fetch. So can I say for pre-computation, I need hash. I need a hash. And over here, for simplicity purpose, let's take 13 because I know at max the size can be till 12. Whatever the problem states, if the problem states the maximum size can be till 10 to the power 5, then you will go across and say 10 to the power 5. If the problem states 10 to the power 6, you go across and declare it. Over here, I've kept it simple. I've said that maximum size will be 12. So I require a size 13 because in order to have the 12th index, I need a size of 13 because the last array index is 12. All of us know that. Now, the pre-computation was very simple. I will go like this to the array. This is the iteration of the array. Now, I know for array element, I have to go to that index and do a plus one. So I say, hey, go to that index, which is array of I, because that is the index where I have to go. And I have to tell him, can you increase your value by 1? And he increases because previously it was 0. Now he will, for every number it goes to that index and says plus equal to 1. Once this is done, now I have my hash array ready. So if I go back to the iPad, can I say I have this particular hash array ready after the pre-computation? Because 1 means hash of 1 plus equal to 1. So it goes to this and does a 1. And similarly for this number, similarly for this and equal to 1. My hash array ready. So if I equal to 1. Once this is done, now I have my hash array ready. So if I go back to the iPad, can I say I have this particular hash array ready after the pre-computation? Because 1 means hash of 1 plus equal to 1. So it goes to this and does a 1. And similarly for this number, similarly for this and for this. This hash array is ready. The input is different, but it's okay. Once the hash array is ready, you have the number. So you just fetch it. So you say cout of hash of number. This is the number of times it appears. And you can just go ahead and do this. I'll go ahead and quickly run this and see if it is running fine. So if you see, these are the answers. How many times 1 appears? Twice. How many times 4 appears? Zero. How many times 2 appears? Once. How many times 3 appears? Twice. How many times 12 appears? 0. Depending on what is the maximum size of the array, you declare the hash. Now, a question that might come up to your mind. Striver, in this you said the array could be having a max element till 12. So it is very obvious that you declare an array of size 13 because the last index then we will get as 12 and we can keep how many times 12 appears. But what if I tell you that the maximum array element can be till 10 to the power 9? Like it can have numbers till 10 to the power 9 or maybe 10 to the power 12 or maybe 10 to the power 15. What if they have larger numbers?
कौन सा है? ये आपका क्वेश्चन है, ठीक है? दोबारा समझते हैं। मैंने कहा कि मैंने आपको इनपुट के अंदर ये स्ट्रिंग दी है, ये आपका इनपुट है। आप मुझे आउटपुट के अंदर सिर्फ इतना बता दो कि भैया मैक्सिमम अकरिंग कैरेक्टर कौन सा है। तो यहाँ पे अगर आप ध्यान से देखें तो ए कितनी बार आ रहा है, यहाँ पे अगर मैं लिख दूं तो ए कितनी बार आ रहा है, एक यहाँ पर आया, एक यहाँ पर आया और एक यहाँ पर आया, 3 बार ए आ रहा है। फिर बी कितनी बार आ रहा है, बी एक बार यहाँ आया, एक बार यहाँ पे आया, 2 बार आ गया जी। फिर सी कितनी बार आ रहा है, सी सिर्फ एक बार आया। फिर डी कितनी बार आया, डी सिर्फ एक बार आया। फिर ई कितनी बार आया है, ई सिर्फ एक बार आया। एफ कितनी बार आ रहा है, एक बार आया। तो मैक्सिमम ऑकरिंग कैरेक्टर कौन सा है, हमें साफ साफ दिख रहा है कि ये मैक्सिमम है। तो हमारा आंसर क्या हो गया, ए हो गया। तो मेरा आंसर क्या आ रहा है यहाँ पे, मेरा आंसर आ गया जी ए जो है वो मैक्सिमम ऑकरिंग कैरेक्टर है। इस क्वेश्चन को अगर मैंने आपको सॉल्व करने के लिए दिया होता तो आप किस प्रकार सॉल्व करते? अब तक आपने बहुत सारे डेटा स्ट्रक्चर पढ़ लिए हैं, ठीक है, आप अच्छा खासा सिलेबस कवर कर चुके हैं डीएसए के अंदर, ठीक है। तो अगर मैं आपसे बोलूं कि दोस्त मुझे मैक्सिमम अकरिंग कैरेक्टर बताओ, तो आप क्या अप्रोच लगाते हैं यहाँ पे? आपकी एल्गो क्या होती? भैया मैं ये सोच रहा हूँ, बहुत सिंपल है। मैं ऐसे कर लेता कि पहले मैंने पकड़ा ए का मैंने निकाला काउंट, ठीक है, और उसको अपने आंसर में सेव कर लिया, कि यार आंसर में सेव कर लिया ए जो है वो इतनी बार है, ठीक है। और ये मैंने एक लूप चला रखा था यहाँ मैंने एक लूप चला रखा है जो कि ए से लेकर जेड तक जाएगा, और हर किसी के लिए मैं अपना आंसर निकालता जा रहा हूँ, जो भी मैक्सिमम होगा उसके द्वारा करता जाऊंगा। मैंने बोला ठीक है, कुछ समझ आ रही है। या फिर किसी बच्चे की एल्गोरिथम इस प्रकार हो सकती है कि भैया मैंने क्या किया, मैंने ना एक एरे बना लिया। अब एरे में तो यार इंडेक्स जो होते हैं वो इंटीजर होते हैं, ये इंटीजर होता है ना 0 1 2 3 4 5 ऐसे करते करते। तो मैंने मान लो अभी मान लो लेट्स से इसमें अजम्पशन हमने ये ले ली कि इसमें सिर्फ लोअर केस लेटर होंगे, हमने इसमें अजम्पशन ले ली कि इसमें सिर्फ लोअर केस लेटर होंगे, यानी ए से लेके आप जेड तक जाने वाले हो सिर्फ स्ट्रिंग के अंदर। तो एक बच्चे ने मुझे बोला कि भैया मैंने एक 26 साइज का एरे ले लिया, तो इस एरे का साइज क्या हो गया 26, और मैंने बेसिकली ये मान लिया कि 0 जो है वो दर्शाता है ए को, 1 जो है वो दर्शाता है बी को, ऐसे करते करते 25 जो है वो दर्शाता है जेड को, या कुछ बच्चे जी बोलते हैं, ठीक है। तो इसी प्रकार मैंने सिंपल सी चीज करी, मैंने अपनी स्ट्रिंग ली, मैंने क्या किया, एक लूप चलाया i इज इक्वल टू 0 से लेके जो मेरी स्ट्रिंग है उसके साइज तक, और मेरे पास करेक्टर आ गया कैर ch इज इक्वल टू जो मेरी स्ट्रिंग थी उसका ith करेक्टर उठा लिया मैंने, बहुत बढ़िया, ठीक है। अब मैंने क्या किया, मैंने इस एरे में जो ये एरे मैंने बनाया था, लेट्स से इसका नाम,
Can we declare an array of size 10 to the power 9 plus 1 plus 9? Yes. But we will. So does when you say now a question maximum size of the array? You declare the hash. Now, a question that might come up to your mind, Striver, in this you said the array could be having a max element till 12. So it is very obvious that you declare an array of size 13 because the last index then we will get as 12, and we can keep how many times 12 appears. But what if I tell you that the maximum array element can be till 10 to the power 9? Like it can have numbers till 10 to the power 9, or maybe 10 to the power 12, or maybe 10 to the power 15. What if they have larger numbers. Can we declare an array of size 10 to the power 9 plus 1? Because apparently that is what we are seeing. If there was an array of size at max till 12, we declared a size 13. So if the array has max element till 10 to the power 9, can we declare an array of size 10 to the power 9 plus 1? The answer to that is no, you cannot. The maximum size array that you can declare is 10 to the power 6 if it is of integer. Inside, very important, inside main, what does it mean? If I go back to the code, this is where you declare. If you're declaring it inside main, it can only go up to 10 to the power 6, like somewhere near about. You cannot declare something like 10 to the power 7. This will throw you segmentation fault. It will not be able to allocate that much memory. But, if you go across and declare it somewhere globally, which means over here, if I go across and declare somewhere globally, I can actually do it till 1e7, which is 10 to the power 7. So if you declare globally the array can go till 10 to the power 7 as well if it is declared globally. Like 10 to the power 7 plus 1 might also work. Near about 10 to the power 7, it will go. But if it is declared globally, very, very important. This is something which I'm talking for integers because we are dealing with hashing. For Boolean, yes, for Boolean, this value will be, if you're declaring a Boolean array, inside int main, you can go till 10 to the power 7. Globally, you can go till 10 to the power 8. You can run them and see. If you declare anything like 10 to the power 8 inside, yes, inside your int main, it is going to throw you a segmentation fault. So let's go into the code editor and imagine instead of 13, I said 10 to the power 7. Okay. And now let's try to run this and see if it is taking 10 to the power 7. So if you look at the terminal, it actually says there is a problem because the memory size is something which it cannot allocate. But the moment I reduce 1, 0 and I try to rerun, you will see that this is actually running fine. Let's run this. You see it is running fine. And if I add one more 0 and I go across and declare this globally, you will actually see this is like, you don't need to give 0 because if you declare globally, everything is initialized as 0 instead of garbage values. So if you go over there, I declared it. Hey, what is the problem it's giving? Oh, shit. Let's run this. Hash is ambiguous because, okay, let's do double hash because the name is something which is already taken. Let's now run it. And you see it is working fine. If I declared it globally as 10 to the power 7, it did run fine. So this is something which I wanted to tell you. If you are using array in order to do hashing, you can only go up to 10 to the power 6 inside a main or 10 to the power 7 globally, not beyond that. For something like 10 to the power 9, what will we be using? That is something which we'll be discussing in the later half of the video. So make sure you watch the video till the end. So till now, what have we learned? We kind of learned about number hashing. If there is a problem which requires number hashing, we can use arrays to hash them, right? What's the next thing that we will be learning? That is something as character hashing. Can we do character hashing using arrays? Yes, we can. And that is something which we will be learning. Imagine I give you a string like A, B, C, D, A, B, E, F, C. And I give you certain queries. And I ask you, how many times does A appear? Can I say once, twice is what A appears? How many times does C appear? If I ask you how many times C appears, it will be 1 and again twice. How many times Z appears? It will be 0. If you look at over here, that doesn't appear. And similarly, I can give you a lot of other things like Q queries. I can ask you Q times A, B, C. I can give you any character, and it is your task to tell me how many times does that character appear in this particular string. Again, what is the standard procedure? The standard procedure is very simple. You pick up A and you iterate in the string and you say A equal to A. Yes, count A equal to 1. A equal to A here, count A equal to 2. So you just basically iterate through the string And in a similar way, you compare the character with each of the characters and you count it. So if I have to write the pseudocode, this is how the pseudocode will look like. You take the character C and you probably take the string C. And what you do is you keep a counter 0. And now you go through the string I equal to 0. Imagine the size of the string is n, character C. Then I will do a counter plus plus. And at the end of the day, I can return that counter. So this is what the simple pseudo code will be. For every character, you go ahead. Again, if you do the similar thing for Q queries, how much time will you end up taking? For every query, you are taking n. So for Q queries, you will be taking big O of Q into n time, similar to the previous problem. So the question is, can you hash them into arrays? And the answer to that is yes. So the question comes up, how do you hash them using arrays? Because if we remember, the arrays have indexes like 0, 1, 2, 3. And if I have to talk about these characters, imagine, I'm strictly stating, imagine the array only has lowercase letters. Imagine the array only has lowercase letters. In that case, how can you hash? Now, I know lowercase means it will have A, B till Z. How many elements? I know there will be 26 elements because those many elements is what we 25 or 26. So I know there will be 26 characters, 26 lowercase characters. So if I have to practically think, can I have an array of size 26? I'll be like, yes, I can. So imagine if you have an array of size 26, what will it be indexed from? It will be indexed from 0, then to 1, then to 2, then to 3, then probably to 4, then probably to 5, then probably to 6, and so on till 25. Can I say this? This will be the array indexing. Can I say this? Since I know there are 26 alphabets, can I correspond A to 0? Can I correspond B to 1? Basically, I'm mapping them in my memory. I'm saying, okay, wait, can I say A to B, the 0th index? I do not have any relation, but I will say, I'll assume A to be this, I'll assume B to be this, C to be this, and this to be Z. Can I say this? For every character, I will have an index. I will. Simple as that. So if I can do that, I think my problem will be solved. Now you might have a question in your head. So straight away you are saying A will be this, B will be this, C will be this will be this. But how do I program it? Because in program, I cannot visualize. I need something which works programmatically, code-wise. So if I have to talk about F, I can visualize over here that F is 5. But how do I do that in program? This is where something like ASCII value comes in. If you do not know about ASCII, it's basically American Standard Code for Information Interchange. So if I have to show you the ASCII, so there are 256 characters. And this is how the ASCII looks like. So if I just scroll across, these are the ASCII values for everyone. The digit 0 has an ASCII value of 48. The digit 1 has an ASCII value of 49. Going across the uppercase A, the uppercase A has an ASCII of 65. If I go across, the lowercase a has an ASCII of 97. The lowercase z has an ASCII of 122. What do I mean by ASCII? So imagine if you're writing a code where you say int x equal to character A. So what will x store? Because you are storing a character into x and x is an integer data type. So what happens is this A is converted. Yes, this A is converted into its ASCII. And this is a small a. So the ASCII is 97. The x stores the ASCII of A. That is 97. Got it? It will not throw a syntactical error. Instead, it will typecast it. So we know about ASCII. So something I know for sure is small a is 97 and small z is 122. So how can you represent now? It's very simple. So imagine you have to represent for f. So you say f minus a. What is f's ASCII value? If I look at the f's ASCII value, that's 102. Because when you're doing a subtraction happens between two integers. So computer says, what's an integer? He says 102 because that is my ASCII. What is the ASCII of smaller a? 97. So I get 5. You get 5 and that is what you required. If you require for A, that's A minus A equal to 0. If you require for B, that's B minus B equal to 1. If you require, B minus A equal to 1. If you require for C, that's C minus A equal to 2. So apparently, the formula that you need is character minus A. If you do this, you get the corresponding index in the hash array, and then you can easily index it. You can easily hash it. So imagine you are having at A, you do A minus A, you get 0. So you go to 0 and you say 1, right? Next is B. So you do B minus A, that is 1. So you do a 1. Next is C. You do C minus A, that's 2. You do 1. Next is D, that's D minus A. So you go and do over here. Next is A, that says A minus A equal to 0. So you do a 2. Next is B, you do a 2. Next is E. E minus A is nothing but 4. So if E minus A is 4, you go to 4 and do A. F, F minus A is 5. So you go and do 1. C, C minus A is nothing but 2. So you do a 2. Done. As simple as that. This is how you hash it. You require 26. And imagine if the string contains uppercase as well. You just saw that you have 256 characters in total. So you can just go across and create an array till 256 size. And this time you don't have to subtract anything. For smaller a, the value is 97. So the smaller a will get at 97. For smaller b, the value is 98. So it goes to 98. Simple. Just because you just had lowercase letters, that is the reason you took a 26 size array. You could have taken a 256 size array. That would have worked as well. I'll show you that in code. So let's look at the input. We're given the string, we're given the queries, and these are the number of queries that we are given, and we have to print the output. So what is the first thing that we are given? String. So let's take string and we say cin of s. We've taken the string. Now we need the queries. So let's take all the queries. Very simple. And I say while q minus minus. And now we need the character. So let's take the character, and that's it. These are the inputs that we have to do. Now we know we need to do some pre-compute because we're performing hashing. And we know we have to fetch it over here in order to print the answer. Let's do the pre-computation. Can I say that I require a hash because we are sure that it will be of size 26. I require an hash of 26 size. And now I will go across the string. So in order to go across the string, this is one of the ways. You say s dot size, and then you go across I plus plus, and you say hash of s of I minus a plus plus. So what this will do is, this is your indexing. Character minus a will give you the index at which you have to do it for the hash. And over here, in order to fetch, you say cout hash of c minus a, because the index, in order to get the index, it's character minus a. That's what you do. You can go across and do an endl. I'll go across and let's quickly run this off and see if it is running fine. It is. We saw that it is giving us the correct answers. Now, we took hash of 26. I know that was done because we knew that they were just lowercase letters. Imagine it doesn't state you that it has just lowercase letters. In that case, we know the number of characters that exist is 256. I'll do 256. Instead of doing this, I'll do s of I. If it's A, it goes to 97. If it's B, it goes to 98. So, and over here also, I don't do anything. Even if you do this, this is still gonna run fine because it's taking a bigger size, but it's mapping it correctly. Just because we did not require uppercase and all the other characters, I took it of size 26. If it doesn't states about the exclusivity of the characters, you have to take 256. This is how you hash all the characters. So are there any complications in order to hash characters? Because in number hashing, we saw that if the number goes till 10 to the power 9, there might be a problem. But in character, there will never be a problem because at max, there are 256 characters. An array can store 256 elements. So for character hashing, you don't have to think much. Always prefer arrays, always. And always use this logic, character minus a for lowercase. If there are uppercase, it will be character minus capital A. And if there are all characters, 256, and simply hash the character. It will be auto converted. Yes. If I'm saying s of I, this auto converts itself to its ASCII because hash needs an index, and the index is an integer. The S of I is a character, but it auto casts itself into an integer. Got it? So this is a character S of I, but the hash inside its bracket, hash inside its brackets needs an integer. So even if you write a character, but is a character, but it auto casts itself into an integer. Got it? So it'll be, and if there are always of the characters, you have to take states you that any of the is but case hash if they're all converted. Yes. If I'm saying S of I, this auto converts itself to its ASCII because hash needs an index, and the index is an integer. The S of I is a character, but it auto casts itself into an integer. Got it? So this is a character S of I, but the hash inside its bracket, hash inside its brackets needs an integer. So even if you write a character, it will auto cast itself to its integer value, which is the ASCII value. This is why it works. So coming back to the problem that we had in number hashing. So in number hashing, when we were trying to hash it into the arrays, we saw that we can at max do it till 10 to the power 7. That also if we declare the array globally. And for numbers exceeding 10 to the power 7, like 10 to the power 9 or 10 to the power 12 or 10 to the power 18, we cannot hash it using arrays. That is not possible. This is something that we need to solve. And that is where in C++, STL comes in. If you have not seen the STL video, please go back and watch it. And in Java, the collection comes in. So in STL, there are two things. One is the map, while the other one is the unordered map, which I'll be talking in depth. And most of the concepts that I'll be talking about map and unordered map also apply to the hash map. It is just the same stuff, just the writing format is different. And the concept inside it is the same. So let's understand map and unordered map. So till now, we were taking an array, right? If you remember, we took an array of size 13 and then we hashed it. And in C++, let's talk about map. So what happens is, imagine you're given an array, something like 1, 2, 3, 1, 3, 2. Imagine you're given something like this. So in C++, what happens is, map is a data structure. So I'll just represent this with a bucket as well. So what you do is you say, okay, I know there has to be a key. What is a key over here? So this is the key. The number is the key. So the number is the key, remember this. And there has to be a corresponding value to it. And the value over here is the frequency. So this is how it is defined. You basically say, okay, what is your key? Key is your number. How many times it appears is the value. This is what you do. As simple as that. So what I do is, okay, I know one thing. At the first step, I have 1. So I will say, can you go ahead and if remember one thing, before iterating in the array, if you say MPP of 1, this will return you 0 because it doesn't exist in the map. So the value, the corresponding value will be 0, right? So the moment you go to 1, you say MPP of 1 plus plus. So what will happen? If it doesn't exist in the map, it will go to the map and say 1, you do not exist. So it's 0, it's 0. 0 plus plus is 1. So it will store a key value. Key mapped to a value of. Next it goes to 2 and does a map 2 plus. And it sees it doesn't store 2. So what happens is it goes and stores 2. Next it goes to 3. Again goes and sees doesn't stores 3. So 3 plus plus. Next it goes to 1 and sees, okay, I already have. Let's go back to that 1 and say, can you please increase my value? So it just increases its value to 2. Next goes to 3, again increases its value to 2. Next goes to 2, again increases its value to 2. So what you need to do is MPP of array of I plus plus. That's what you need to do. And imagine, I'll just erase this. Imagine I had a number like 12. Then what would have happened? So you would have done MPP 12 plus plus. So 12 would have gone as 1. Quite simple. Very, very simple. So something to observe. Over here, even if the number was still 12 and you would have used array hashing, you would have ended up taking a size 13 array in the array hashing. And over here, how many elements are you storing? We're just storing the elements that are required because you require 1, 2, 3, and 12. So 4 elements are stored. Whereas in array hashing, you had to declare a 13 size array if the maximum was still 12 in order to get the 12th index. So this is where map is slightly beneficial. It takes a little less memory because it will just store the elements that are required. If you do for MPP of 4, it is not there in the map. So it will automatically throw you a 0, but it doesn't stores 4. It doesn't stores 4. Got it? So if I go back to the code, you see that you have an n, you have the array, you have the queries, and then you have all the queries. So it's quite simple. You say n, you say cin of n, and then you say int array of n. Then you say for int I equal to 0, I lesser than n, I plus plus. And then you go across and say, let's take these arrays, values, array of I. And now you need the queries. So let's take the queries, int q, cin of q, and now you do while q minus minus, and then you take the number, and you take number over here, and you say C out. This is where you fetch. So you pre-compute here, and then you fetch it over here. So we have to do the pre-compute. So what you do is map of key. Now you know the key is a number which will be integer. If the number goes till like 10 to the power 9 or 10 to the power 12, then you could also go ahead and take a long, because that will be bigger numbers, or you can take long as well. Depending on the size of the numbers, you can define your keys, data type. Done. And now what you do is you go across and say int I equal to 0, I lesser than n, I plus plus, and you say map of array of I, and you do a plus plus. Quite simple. And in order to fetch it, you say C out of map of number. And once you've done this, you could go ahead and say, can you please run this? And if you run this, you will see that everything is fine. 4 appears 0. That's why 12 appears once. It does run fine. So remember one thing, the map stores all the values in sorted order. This is something which you have to keep in mind. The map stores all the values in sorted order. What does that mean? This will be at the first place in the map. This will be at the second place. This will be at the third place. This will be at the fourth. How can I prove it? What I'll do is I'll go ahead and say, let's iterate in the map. So if you just iterate in the map, this is how you iterate in the map, an auto iterator on the map. And if you do C out of it dot first, up something like this, and do it dot second, this is how you can get it. So if I just try to run this, you will see what will happen. Before printing all of this, it actually shows you one appears twice, and this is how it is stored in the map. So this is how you can also iterate in the map. So let's quickly comment this off. Now you might have a question. You're pre-computing here's driver. That's like running a loop for taking the input and then doing the pre-compute. You can also do this over here. It is okay. Like you can declare this before this, and it still works. And you can just omit. The pre-computation can be done while taking the input as well. It doesn't matter. It will save you one for loop, but that is okay. That won't change anything, or that won't make your program super fast. Why won't it make super fast? Because it's n plus n and not n into n. N into n generates a bigger value. N plus n is like 2n. And if you remember the time complexity, we ignore 2, 3, and all these smaller values. Remember? So we did learn about map. Can this map be used in something else? Yes. You can also use map in string hashing. Now, what is the key over here? If you remember, the key is a character. So what you can do is you can say map of character and store its frequency. So instead of using an array for hashing, you can go ahead and say map of character. And now you can say map of whatever is your character s of I plus plus. This will not be converted into integer. Now your map will be storing something like this. A appears twice, B appears once, C appears once. So depending on what you are trying to hash, that will become your key. And what are you storing? That will become your value. Over here, we are storing the frequency. That's why it's showing plus plus. Got it? In Java, so in Java, there is something as hash map. You can use it. It works in the similar fashion. Now let's talk about something very important. What is the time complexity of this map? So in order to do something like map of something plus plus, that is basically storing in the map. You have to fetch from the map, that is MPP of, you're doing array of I or something like this. So that's fetching from the map. The storing of fetching. Remember this. Storing of fetching. Both of them in a map, takes logarithmic of n, takes logarithmic of n in all cases, in best, in average, in worst, in all cases takes logarithmic of n. Remember this. But there is something as unordered map. There is something as unordered map, which we will be talking about now. So let's go back to the code. So even if I write this unordered, will it run? And if I go ahead and run this, it will actually run. You see the values are getting printed. So even if you take unordered map, it does run. Now, what is the meaning of unordered map? So as the name recommends, unordered. So imagine now I go across the map and try to print it. So if you remember in the map, it was storing everything in this sorted fashion. But over here, by the way, just my bad. comment this off. In the map, everything was stored in the sorted order. But over here, if you see, there is no particular order. There is absolutely no order. It can change on every program. Like over here, it's 312 to 1. If you run the same code on some other compiler, it might be having some different order. So the order is something which you cannot decide. So as the name recommends, it is unordered. But then you might ask, what is the advantage of using this? Let's talk about this. When you are storing something in the map, which you are doing, and when you're fetching in the map, the average and the best time complexity is a constant one. The average and the best is average, like in most of the cases. In most of the cases, it will be big of 1 for storing and fetching. But there is something as the worst case, and that ends up taking linear time. Linear time. What do you mean by linear time? This is nothing but the number of elements in the map. This is nothing but the number of elements in the map. When I talk about n, if I'm talking about log n, this is nothing but the number of elements in map data structure. Depending on the number of elements, the time will be computed. So the average in the best case will be big of 1. In most of the cases, it will be big of 1. In very minor cases, it will happen once in a blue moon. If the problem setter is extremely like, he just wants to make your code fail, he might end up giving a worst case that might end up taking big of n, and your code apparently will take n squared. Because imagine if this line is taking big O of n and you're running a loop over it, so it's like n and this is n. So n into n happens. But if this line is big O of 1, then it becomes n into 1. Most of the times, what you need to do is you need to use unordered map. Yes. If it fails, if it gives you a time limit exceeded, that means taking a lot of time, then you switch back to map. But the first preference should be unordered map, because the worst case very rarely happens. I know it is a worst case, but it very, very rarely happens. Why does the worst case happens? Because of internal collisions. Because of internal collisions. So since we are talking about collisions, let's understand how does hashing work. Because if you remember, I told you that the moment it crosses 10 to the power 7, an array hashing cannot be done. So how is a map data structure created? Will someone ask you? Might not. Like in interviews, they generally don't ask that much. Even if they ask, only telling them about division method will work. These two methods are something which you just need to know the names. Might come up in your semesters, but this is the method that you have to understand. So how is the internal map designed? Because if I'm talking about design, I know I can design an array hash. But for numbers like 10 to the power 18, how do I store it? This is where internally you might see like these map data structures are implemented in different ways. They might be using division method. They might be using folding, mid square. They are implemented in a very complex way. You don't need to know it. But let's understand what is a division method. Because if I take the division method, then I might be able to explain you what is collisions. So let's understand the division method. So imagine, I'm giving you numbers like, in an array, I'm giving you numbers like 2, 5, and then 15, and then 55, not 55, not 15, let's take 16, and let's take 28, and let's take 139. Okay, so these are the numbers that I've given. So you can do array hashing, because I'm not talking about map. If you have to do array hashing, you can actually go ahead and create an array of size 140, where you go like 0, 1 and till 139, because if you create an array of size 140, you'll get 139, and then you can hash it. But imagine I tell you, you cannot create an array for a time being. You cannot create an array of size greater than 10. This is not allowed. An array of greater than size 10 is not allowed. I'm taking very smaller values in order to explain. You can map this to bigger values. So you can map this to the bigger problem that we are trying to solve. In the bigger problem, imagine you have number like 100, 10 to the power 18, and then 10 to the power 16, and then 10 to the power 4. And the maximum size allowed is 10 to the power 7. Beyond this, it's not allowed, right? So it's the same problem we are solving. We have bigger numbers, but as of now, we have a restriction that you cannot create an array greater than size 10, greater than equal to, like at max 10 is allowed, not more than. How will you do it? So this is where something like a division method comes in. Yes, this is where something like a division method comes in. What does division method say? Division says, okay, I just have 10 size array allowed, which means I can only store 0 to 9, right? So it's like 0, 1, 2. So as I said, an array of greater than size 10 is not allowed. So
अगर आप लोग डेटा स्ट्रक्चर एंड एल्गोरिदम्स के अंदर हैश मैप्स को पढ़ना चाहते हो या हैश सेट्स को पढ़ना चाहते हो तो इस चीज़ को डेफिनेटली फॉलो करना ऑर्डर वाइज। सबसे पहली बात, मैक्सिमम एक हफ्ता ही लगेगा आपको हैश मैप्स हैश सेट करने में, इनफैक्ट उससे काफ़ी कम भी लग सकता है। इसके अंदर आपको क्या करना है, स्टार्टिंग में बेसिक एसटीएल देख लेना या फिर कलेक्शन फ्रेमवर्क अपनी पर्टिकुलर लैंग्वेज का, और ऑर्डर्ड मैप और अनऑर्डर्ड मैप दोनों के बारे में देखना, इनकी टाइम कॉम्प्लेक्सिटीज़ के बारे में समझना। अब इसके बाद डायरेक्टली थ्योरी पे जंप मत करना। सबसे पहले तो एरे और स्ट्रिंग के बेसिक क्वेश्चंस को सॉल्व करना एंड समझना कि कैसे हम यूज कर पा रहे, किन क्वेश्चंस में यूज कर पा रहे। इसके बाद आपको एरेज और स्पेसिफिकली स्ट्रिंग्स में स्लाइडिंग विंडो और 2 पॉइंटर एल्गोरिदम्स के साथ साथ हैश मैप्स का इस्तेमाल करना अच्छे से। फिर इसके बाद लिंक लिस्ट के 1-2 क्वेश्चंस होते हैं जो हैश मैप से सॉल्व होते हैं, उनको डेफिनेटली सॉल्व करना, और बाइनरी ट्री के भी 1-2 क्वेश्चन होते हैं। एंड लास्टली आपको करनी है थोड़ी सी हैश मैप्स की थ्योरी देख लेना कि एक्चुअली में वर्क कैसे करता है, हैश कोड क्या होता है, हैशिंग क्या होती है, हैश टेबल क्या होता है, एंड कैसे हैश मैप्स वर्क कर रहे हैं, उसके बारे में बहुत ही बेसिक अंडरस्टैंडिंग आपको होनी चाहिए। अगर
this is what we can have at max. So 0, 9. And we will be using the division method in order to hash it. How will we use the division method? It's very simple. If we have 2, whatever number we have, we will try to modulate it with 10. So for 2, the corresponding value will be 2. So I'll go to 2 and I'll say it appears 1. For 5, I'll modulate it with 10. I'll get 5. For 16, I'll modulate with 10. I'll get 6. For 28, I'll modulate with 10. And I will get something like, what will I get? I'll get 8. For 139, I will modulate with 9 and I'll get 9. I'll do a 1, right? Now what I do is, I have used the division method to kind of trim down the number and have been able to somehow array hash it, right? So this is what the division, but your brain might be thinking a lot of things. I'll come to that one, don't worry. So this is how the division method works. Now if someone does ask you, and someone does comes up and asks you, hey, how many times 139 appears? So you say 139 modulo 10 is equal to 9. What is the value at 9? It's 1. So it appears 1 time. That's how you retrieve. The division method is modulo 10. So that's how you put it and that's how you retrieve it. So that's how you trim down the number. Now you might have a lot of questions. I'll come to each of these questions now. Now what I've done is I have kind of drawn the array in the vertical fashion. And the first question that might come to your head is, what if on modulo 10 they are same numbers? Because this is 2. So now I'll do it a slightly different. This is 2. So I'll take, okay, we have 1, 2. We have 1. We have 5. We have 1, 5. We have 16. We have 1, 6. So I'll probably store the numbers in some chaining. This is what you call as linear chaining. Again, these things will be done using linked list. You don't need to know, just understand the logic and concept. 28 modulo 10 is 8. So in 8 you put 28. 139 modulo 10 is 9. So in 9 you say 139. 38. Here comes the collision factor. This was also modulo 8. This was also modulo 8. So you cannot store. So you chain it. You say, I have one more 38. Next, 48. Again you do a modulo 10 and you get 8. So you go and say, chain it. And this time again you get 8. But this time you get 28. So you chain it. But you do not chain it in the back. Instead of that, you chain it somewhere like this 28 and back over here. And you kind of break this. This is something which can be done using linked list and in a very simple way. You'll be learning learning this in linked list. So you chain it. 28 is there twice. And then again you get 18. So you chain it something like 18. And then you make 28. It's like 18, 28, 28, 38, 40. So you chained it, right? So this is how it works. Now if someone comes up and asks you, how many times 28 appears? So what we do is, we say 28 modulo 8, we go to 8 direct. And we know there will be limited numbers. And we know it is sorted. So there are a lot of search algorithms which are applied internally. And you can easily do a binary search on it. And you'll find that there are 2 numbers. And it can be done in minimal time. Got it? So this was the division method that I did talk about. So you can do some chaining and you can keep it in certain ways. Imagine you had 22, then this will be chained here. So chaining can be done, and you can always keep them in limited memory storage. So do you need to implement this? No, you just need to understand the concept. What then? But Trevor, then what is collision? So in order to find out how many times 28 appeared, what did you do? You just went to 8 and then you figured out 28 appears twice because it was chained in a sorted order. Because it was chained in a sorted order. So it is quite easy to find out 28 twice. But if just realize this 8, this chain would have been ultra huge. Do they use the division method internally? No, they use some method which is a mixture of everything. Depending on your input, they find out some method and they use it. Imagine they're using a method internally which falls under collision. What is collision? You're given an array. Imagine they're using division. Just imagine. They are not. Just imagine. And I give you something like 18, 28, 38, 48, and all the arrays are ending with 8. So how will the chain look like? The chain will be on 8, you will have all the numbers. All the numbers. So apparently, all the other memories are not used. And in 8, you had all the numbers. It's a huge chain. Collision happened. Everyone went to the same hash place. Collision is this. Everyone went to the same hash place. If everyone went to the same hash place, you have to find it out. It's going to be tough. It's going to take a lot of time. Got it? This is what we mean as collision. Whatever hash they're using, remember this. Whatever hash they're using internally can be anything. You cannot say what they're using. Whatever hash they're using, it ends up that all your keys end up at the same hash value, hash index, ends up at the same hash index. This is when the worst case will happen and be governed. Now you understand why I said it's a very, very minor case. It might not happen. It like the problem setter has to be extremely brilliant. He has to find out, and then he might be able to do it. But it's an extremely rare case to happen. This is why in interviews, when you talk about the time complexity, you tell them in the best and the average, if I'm using unordered map, it's big of 1. If I go across the worst case, it will be big of n. So this is how it works. So I hope you've understood the division method. This is the normal simple division method. And linear chaining is done if there are multiple values. Folding and mid square method, not required. Not required. I just told you the division method because I wanted to explain you what is collision. And in order to explain collision, then I could have explained you why big O of n is such a, like, it never happens. It just happens once in a blue moon. Another thing. Can the key be an integer? Yes. Can it be a double? Can it be a character? Can it be a string? It can be anything. It can even be a pair of integers. It can be a pair of 2 guys as well. This can also be a key. Key can be anything. Any data structure can be a key in a map. But when it comes to unordered map, you can only have individual data types. You cannot say pair of int, comma int to be a key and the value to be int. This cannot be a key in unordered map. This cannot. But in map, any data structure, any particular data type can be a key. In unordered map, it's limited to integer, double, character, string. You cannot take like pair of int, comma int, or something like a vector of int. It will not allow you. Remember this in mind. A lot of you might be thinking this chaining stuff and everything. No need to worry. No one is going to ask you in interviews. It's just for understanding what are collisions, and if someone will ask you about this complexity, just for explaining. No one is going to ask you to implement this. No one. Trust me on this. So coming back to the course, you can do this. Can you do this? Find the highest and lowest frequency element. I'll give you this as homework. It's quite simple. The hint is you can use map or you can use array hashing. And then depending on how many times they appear. In map, you can iterate like this. And this is what has to be maximum if you're finding highest frequency. So try to do this. It's quite simple. Some if-else statements will do. This will be your homework. Once you've done this, you can put the code in the comments. I'll check it out and the other people will also get help from it. So with this, I can say that the learn the basic stuff module is completed from the Strivers A to Z course. In the next module, we will go to step 2. So guys, I hope you've understood everything I taught. Just in case you did, please hit that like button. And yeah, to follow our tradition, make sure you comment understood in the comments so that I get to know that you've understood everything. And if you're new to our channel, what are you waiting for? Hit that subscribe button, because that is the only thing that keeps me motivated to make such kind of content. And
दर्शकों, इनकी पहली फिल्म ब्लॉकबस्टर थी हीरो। उसके बाद मेरी जंग, मैं बलवान, आंधी, तूफान, इनाम 10,000, दिलवाला, शहंशाह, परिवार, घर हो तो ऐसा, घायल, घातक, आज का गुंडाराज जैसी सुपर हिट फिल्में देकर इन्होंने बॉक्स ऑफिस पर अपनी अलग जगह बना दी थी। माधुरी दीक्षित मैम भी इनकी फिल्मों में सपोर्टिंग रोल करती थी। दामिनी में तो इन्होंने भर भर के दामिनी गिरा दी। ये भारत की इकलौती एक्ट्रेस है जिन्होंने यश चोपड़ा, बी.आर. चोपड़ा, रमेश सिप्पी, सुभाष घाई, मनोज कुमार, राजकुमार कोहली, राजकुमार संतोषी, राहुल रवेल, जे.पी. दत्ता जैसे सभी दिग्गज डायरेक्टर्स के साथ काम किया। इंडिया फर्स्ट मिस इंडिया टर्न सक्सेसफुल एक्ट्रेस, मैजिकल मीनाक्षी शेषाद्री।
तुम्हारी जितनी भी होते हैं, फॉर एग्जांपल इसमें हमने ये भी तुम्हें सिखा रखा है कैसे डीपी वगैरह कर सकते हो, बट इस वाली में तुम्हें बेसिक्स ऑफ जावा मिल जाएगा। आगे सब चीज़ों के साथ रिसोर्सेज अटैच्ड है। बेसिक्स ऑफ जावा तुम यहाँ से सीख सकते हो, और C++ के रिसोर्सेज भी मैंने ऐड कर रखे हैं। बेसिक्स ऑफ C++ तुम यहाँ से सीख सकते हो। इससे तुम्हें पता चल जाएगा एरियाज क्या होते हैं, स्ट्रिंग्स क्या होते हैं, तुम्हारे पॉइंटर्स वगैरह क्या होते हैं, इसके अलावा तुम्हारे वेरिएबल्स क्या होते हैं, फॉर लूप कैसे चलता है, इफ एल्स कैसे चलता है, एंड यू कैन गेट स्टार्टेड विद एनी वन ऑफ द लैंग्वेजेस। ठीक है, सबसे पहले तुम्हें ये करना है, स्टार्टिंग के 5 से 10 दिन के अंदर जल्दी से एक लैंग्वेज सीख लेनी है। तो जब तुम्हें जावा और C++ के बेसिक्स सीख लिए होंगे, उसके बाद तुम्हें क्या करना है, डे 1 और 2 में स्पेस एंड टाइम कॉम्प्लेक्सिटी सीखना है। स्पेस एंड टाइम कॉम्प्लेक्सिटी का मतलब क्या होता है? स्पेस का मतलब होता है कि तुम एक्चुअली जब ये रन कर रहे होगे तो कितनी स्पेस ले रहा होगा तुम्हारा प्रोग्राम, एंड टाइम का मतलब होता है कितना टाइम लगेगा इसको एक पर्टिकुलर आउटपुट लाने के लिए। काफी इंपॉर्टेंट है, जब भी तुमको इंटरव्यू दे रहे होगे तो तुमसे ये चीज पूछी जाएगी, एंड इट इज वेरी इंपॉर्टेंट, चाहे किसी भी कंपनी का तुम इंटरव्यू दे रहे हो। इवन अगर तुम किसी सर्विस बेस्ड कंपनी को भी टारगेट कर रहे हो तो वहां पे भी इस टाइप के क्वेश्चन तुम्हारे आते हैं कि इस कोड को एनालाइज करो एंड बताओ इसकी टाइम कॉम्प्लेक्सिटी कितनी है। नेक्स्ट हमारा